Hey guys, we are on day one, and we're going to talk about degree and end behavior of polynomials, okay? And so the degree of a polynomial is the highest exponent when it is in standard form, okay? It's either an even number for your degree, or it's going to be an odd number, okay, for your degree, depending on the highest exponent. All even degree polynomials, okay, share a certain characteristic about their end behavior, as do all odd degree polynomials. And we're going to figure out what that characteristic is by looking at the following four functions in 1, 2, 3, and 4, okay? And so in number one, we're going to sketch the function below, and I've actually already put it in my calculator, and you guys can do the same. It'll just take us a little bit longer. So I've already sketched it. So our polynomial, when this is in y equals in our calculator and you hit graph, is going to look something like this. It's going to go down, back up, turn around, go back down, and then come back up. Okay, and so that's what our polynomial is going to look like. And we are going to go ahead and talk about as x approaches negative infinity, and on the x-axis, negative infinity is this side. And so we're looking at this end and it is going up. And so we're going to go ahead and say that y approaches positive infinity. Okay. As x approaches a positive infinity, which is on the x-axis on the right-hand side, is positive infinity, and therefore we're going to look at this end, and that end is also going up, so we're going to say y approaches positive infinity on this end as well. Okay, so notice both ends are going up, and therefore both ends are approaching positive infinity. Okay. The degree of our polynomial is the highest exponent, which is 4, and that is considered an even number, and therefore this is an even degree polynomial. Okay, and we don't know the characteristic yet of evens, but if we look at another even one, like in number 2, and this is also an even degree because the highest exponent is 8, and so the degree is 8, which is also an even number, and we're going to see if there is a characteristic that we can figure out. So if I go to y equals in my calculator and I type this equation in, what we're going to find out is that it looks like this. It goes up, then down, turns around, goes back up, and then back down. Okay, and so as x approaches negative infinity, on the x-axis, negative infinity is on the left-hand side, so we're looking at the left end there, and it is going down, and we're going to say that y approaches negative infinity. If we're looking at the x approaching positive infinity happens on the right side of the x-axis, and that end on the right-hand side is also going down, and so we'll say y approaches negative infinity as well. All right, and so what we have to get from these two is, because these are both even degrees, they have what we call same end behavior. Whether both ends are both going up or both ends are both going down, even degrees always have same end behavior. All right, so even degrees is same end behavior. Okay, and now we're going to go ahead and look at the characteristic of odd degrees down in number 3 and 4. In number 3, okay, we can tell that that is an odd degree because the degree is 3, which is an odd number. Okay, and if I put this into y equals, which I've already have, and I hit the graph, my sketch will look something like this, where it goes up, touches the x-axis, comes down, and goes back up. Okay, this is an odd degree. All right, as we look at x approaching negative infinity, which happens on the left-hand side of my graph, the left end is heading towards negative infinity, so y approaches negative infinity. And as x approaches positive infinity, which happens on the right-hand side, we'll look at the right end, and the right end is going up, and so we'll say y approaches positive infinity. Okay, and so you can see it does not have the same end behavior like number 1 and number 2 do, because it's not an even degree, it's an odd degree. Okay, we'll see if number 4 follows the same characteristic, because this is a 5 as your highest exponent, so the degree is 5, which again is an odd number. Okay, and if I put this equation into my y equals and I hit graph, this is what you would look like. So it would go down, turn around, come back up, turn around, and go back down. And if they're asking about x approaching negative infinity, which happens on the left-hand side, we look at the left end and we would say route y is approaching positive infinity because that end is going up. As x approaches positive infinity, which happens on the right-hand side, we look at the right-hand end and that is going down, and we'll say y approaches negative infinity because it's going down. And again, you can see that they have what they call opposite end behavior. Okay, so odd degrees, if your degree is odd, which is the highest exponent, they have what they call opposite end behavior. Your ends are doing the opposite thing. One's going up and one's going down, and that's the characteristic of odd degrees. Okay. So coming down here in the box, it says, what is the connection between the degree type and its end behavior of the graph? And so we're going to say even degree polynomials have same end behavior. Okay, and we haven't talked about this part of it, but we'll go back up and we'll talk about that in a second. Okay, whereas coming down here, when you have an odd degree, okay, polynomial versus an even degree, those polynomials have what they call opposite end behavior. Okay, and now we're going to go back up and look at the very first one, which had a positive leading coefficient because it was a positive x to the fourth, versus in number 2, we have a negative x to the eighth. In number 1, we have a positive leading coefficient, and that had both ends approaching positive infinity. Both ends were going up. All right, so we'll say both ends were going up and they were going to positive infinity. All right. Whereas negative leading coefficient in number 2, we had a negative x to the eighth. That's a negative leading coefficient. Both ends approached a negative infinity in that one. And so both ends were going down. All right. All right. So we're going to go back down to odd degree there. We're going to look at the bottom 2. One had a positive leading coefficient in number 3, and the other one had a negative leading coefficient in number 4. In number 3, the positive leading coefficient was positive x to the third, and that means that the right end, okay, approaches, so looking at the right end, the right side of your graph there, it was going up, all right, and so that's approaching positive infinity. All right. Some people will say that it begins and ends increasing. So it began going up and then it ended going up as well. All right. Whereas your negative leading coefficient in number 4, because it was a negative 2x to the fifth, your leading coefficient there is negative 2. And that negative leading coefficient means that both the right end is going to approach negative infinity. Or some people will say that the graph begins going down and it ends going down. And so therefore it begins and ends decreasing. All right. So we're going to talk about those and be able to come up with them and their characteristics on the next hand page. We'll talk a little bit more and practice a little bit more so that we can get that part down. All right, I'll see you guys on the backside of notes.